Hello, my name is Frank Klaassen and I want to show you a small demonstration about the GCMS. At first, with the GCMS, we're trying to introduce the sample into the system. We do that with the auto sampler. I will start the run. And then it will take a sample. The sample is in the vial here. It will take a sample and inject it into the GC. First is checking all the settings. If all the settings are correct, if the oven temperature is fine. Now first is flushing the needle, making sure the needle is clean. And in a minute you will see that it will inject the sample, and it will try to do that really fast because you want to have the sample in a very short time on the column. Now it will inject. Boom, that was the injection. It goes really fast, and now it will clean afterwards. At this moment the sample is inside on the column and it will have the separation. I cannot show you that here because it's heated in the oven, so I will show what happens there in this system. I will open the door. On the door here you can see already which column, the length of the column, film thickness. And here you can see how the column looks like. So it's a very thin glass capillary. Glass is very fragile, and that's why it has been coated with a protective coating. And now it's not fragile anymore. You can do quite a lot with it, unless you get a small scratch. Because when you get a scratch, it has no protective coating anymore, and it's just glass, so it can break very easily. From the inside of the capillary, you have the coating with the polar or apolar stationary phase. Your compounds are going through the column where you have the separation, and then after the separation you have to detect the compounds. That can be with the FID, in this case it's with the MS detector, and then it goes here into the MS. While we're waiting here, before we can see the results, I already took one measurement before, so we will look what will happen here in the real measurement, but in the meanwhile I will look at the data I measured before. We will get a picture like this. I measured the papain as a reference, and here this peak is the papain. So what happens is here we measure all the masses together, and then you get a height of the signal, and here it's a baseline. Here we get a few compounds, so the reference is not 100% pure, and then here we have the peak of papain. If I look underneath this peak, you see that all these masses are from this peak. The papain has a certain mass, and it's fragmented into fragments, and if it breaks at a spot very easily, it will happen very often, and then you get a very high signal. If it breaks less easy, it doesn't happen that often, and the peak will be less high. So all the masses you get, but also the intensity of the masses, are really specific for a certain compound. So that is like a fingerprint for humans, it's a fingerprint for the compound. We have stored all these data for a lot of different compounds in a library, and we bought a library, and then we can find it back and know what it is. And then when I select here and search in the library, you can see that the upper one is measured by us, and the lower one, the second is from the library. And you can see we find the same peaks and also in the same ratio. And then when we look which compound it is, you can see here that it's a piperine from the library. So that's how a measurement works. And then we go back to our measurement, and now we still see only the baseline, but we will get our peaks very soon. So the first few minutes you see nothing, and that's because it's eluting a lot of solvent, and the solvent is not so good for the detector, and that's why we don't measure the first few minutes. So here we have the two small peaks of pollution that's inside of the reference we saw before. Have to wait half a minute, and then we see the peppery peak. And here you see that the peppery is now eluting from the GCMS. And there it's off. So this is the data I just showed you from a previous injection. So this is the end of the demonstration of the GCMS.